Alright, so today we're covering section 7.5, which is apply the tangent ratio. Alright? And this is part of trigonometry. Alright? So for the next 3 lessons, our objective is students will be able to apply trigonometric ratios, I know that's hard to say, trigonometric ratios to find missing sides and angles. Alright, this is one of my favorite parts of math, so hopefully you guys will like it too. If not, then we just won't talk ever again. Alright? Ready? What is trigonometry? Alright? What is trigonometry? Yeah, trigonometry not so important. I wouldn't make sure you write down the second one. Okay? So trigonometry is a branch of mathematics that uses triangles, and it studies the relationship that exists between their sides and their angles. Okay? So far in our class, we've talked about the angles. So we've talked about how much do they all add up to inside of a triangle. We've talked about the sides. We've talked about using the Pythagorean theorem, right? But we haven't really compared the two yet. Today we're going to compare the angles to the sides. All right? A trig ratio is any ratio, so a number over another one. Remember, a ratio has to be... Ratio has to be... Why is my marker not working? Uh-oh. Let me try real quick. Oh. I know what's wrong. Hang on. Sorry about this. It's fun the first time, and then it gets real old. Alright, let's see if this works. Alright, cool. So remember that a ratio has to look like any number over another one, and that's going to show up a lot today, okay? So a ratio is a comparison between two numbers, okay? We're going to see that a lot today. Sorry about that, guys. Alright. So trigonometry can be roughly categorized into these keywords, okay? These keywords. Alright, now you don't have to write these down. But so trigonometry is frequently abbreviated as trig. And the ones that we're going to talk about in particular today, we're going to talk about the sin, which really stands for sine. So we're going to talk about the sine. We're going to talk about the cosine. We're going to talk about the tangent. Okay? All these other words we're going to use a lot this chapter. Okay? So all these other words are going to come up depending on our problem. Okay? Alright, so we're going to start with a little story time. This is about Chief Sokotoa. Now, he's very famous. Have you guys learned about him in American history yet?
No.
Alright. Incredibly important historical figure. So, a young Indian boy was the son of the local chief. And he wanted to prove to his father and the rest of his tribe that he was ready to become chief. You know, it's a big rite of passage for them. To show his strength, he decided to carry a huge boulder from the riverbank up to his camp. Okay? Along the way, he tripped, though. And he dropped the huge boulder on his toe.
Oh, gosh.
Yeah, exactly. He screamed so loudly, and it was embarrassing. He didn't want to scream. But he screamed so loudly that the entire tribe heard him and ran to help. So his cousins, his father, his son, his friends, right? Not his son, sorry. He's just a young boy. But the young boy ran straight downhill and back to the river, right? So when all of his friends came out, they found him, but he was sitting on the bank of the river, and he was soaking his toe in the water because it was cool. Although the tribe admired his great strength, and they admired his determination and his thoughtfulness, they never forgot that sight of him at the riverbed. So therefore, he was always known as Chief Soka-Toa.
Oh.
I know, it's real lame. However, Chief Soka-Toa is going to be very important to us, alright? And this is called a mnemonic device. You guys have learned about these in biology. When you did, I punched my algebra teacher, what is it?
Yeah.
What are the 5 phases of meiosis? Is I punched my algebra teacher, right?
Yeah.
Interphase, prophase, anaphase.
No. Metaphase.
Oh yeah, metaphase, anaphase, telophase.
Yeah.
Alright? So I punched my algebra teacher, we're doing the same thing here, except we're going to talk about Chief Soka-Toa. Alright? Now what is our mnemonic device? You learned about it already for biology, and you guys know those pretty well, I think. So, some of these words you may have seen before, some of them not. This is very, very important, so please put a box around this. This is going to be the key for the next three lessons, okay? So the S stands for sine. Okay, and I'll explain these in a second. So the S stands for sine. Alright. Sorry, I'll let you set up your table. You okay? The O stands for opposite. As in, when a side is opposite of the other one. The H, what's the word that starts with H that we use a lot in this chapter? Hypotenuse. H stands for hypotenuse. And I want you to draw a little dashed line there. Because, as you remember, it was abbreviated So-Ka-Toa, right? So there's 3 little parts there. So I want you also to draw a little dashed line there. These are going to be 3 separate things, but we're going to remember them with the same name, okay? So Soka-Toa is going to do all 3 of them. So the first one's the sine. The next one, we saw it on the other page, it starts with the C. Which one is it? Cos. Then cos stands for, do you remember? Cosine, yep. So this is cosine. We're looking for an A word. So let's not dirty. Alright, which one of these might be adjacent? Very good. So cosine is the adjacent. And H again is the same thing? Hypotenuse. Okay? And the last one? Anybody remember what my T was from the picture before? Very good. Tangent. What might O be? Opposite. And what would A be? No, same thing as what we did before. Adjacent. Angle was also part of it, but not in this case. That's a good guess, though. And we'll talk about that in a second. All right. You absolutely need to memorize these. Okay?
Separate or all together?
All together. I mean, separately and all together. So these are going to go together. The red, the blue, the green. Okay? But it's easiest if you just remember it all the way. So-Ka-Toa. And that tells you the first letter of each one. Okay? Why do we memorize these? The definition of the sign. The definition of the sign. If sign is abbreviated as sin, you choose the first three letters from each of these to abbreviate. Okay? The definition of the sign is equal to the opposite over the hypotenuse. You see how my trig ratio showed up here? Here's my ratio. It's a comparison of one side to the other side. This is for the sine. So the sine is equal to the opposite over the hypotenuse. So do you see how that so is going to help us remember that? Okay. So then if you guys use the same pattern, what would my next one be? Very good, Mara. So cosine equals, Khalil, cosine is equal to the adjacent over the hypotenuse. Any questions with that? And what would my last one then be? Equals? Good. Okay, easy enough. See how Chief Sokotoa is going to be so helpful? Don't forget about him. American history books just glossed over him, okay? He's a very important historical figure. Yeah, he's Cherokee tribe. No, I'm playing with him. No, he's not real. No.
Oh, well.
I'm sorry. He's a mathematical creation. Yeah. So the tangent is equal to the opposite of the adjacent. Today what we're going to focus on is the tangent. Okay, so today we're going to do the tangent. Alright? Any questions on this? Make sure to please put this in a large box or star it or highlight it or whatever you need to do in your notes, okay? Very, very, very important and helpful. Alright? Sokotoa. Alright? Don't forget how to spell it either. If you spell it wrong, you won't get the right letters. Okay? The tangent ratio. The tangent, whenever you find a tangent, you always find it of a certain angle. So I didn't quite fill it all out in the last page. So I want you to find the tangent of angle A. The tangent of angle A. What that means then is you have to find angle A in your triangle. These, Sokotoa only works for right angles. So this only works for right triangles only. Okay? Where you can use it for non-right triangles, but it's just a little different, okay? For our class, we're going to focus only on right triangles. When you get to pre-calc, you'll do it with, or algebra 2, excuse me, you'll use it with non-right triangles. Okay? So the tangent of A. Well, what was the tangent? It was what over what? Opposite over adjacent. So what you need to do is find angle A, and if you want to just highlight it, like shade it in. Okay? And we want to write as the opposite over the adjacent. Opposite means that it's across from it. You see how it's across from angle A? Okay. Adjacent means what in real life? Next to, right? If I'm adjacent to Julio, it means that we're next to each other, okay? However, notice that there's two legs that are next to A. There's the hypotenuse, the red one, and the blue one, CA, on the bottom, right? Adjacent always refers to not the hypotenuse. The hypotenuse is special. The hypotenuse is always the hypotenuse. Okay? So the leg opposite it would be BC in green. And what's the leg adjacent to it? What is it? CA. Very good. The leg adjacent to it is CA. Notice that we ignored my hypotenuse. But that's okay, because look at my tangent. Is there any hypotenuse in my tangent? No, so we just ignore that. Does that make sense? What I'd like you to do now is fill out tangent of B. Try that one. Remember, we're looking here. We're looking tangent of B. Khalil?
BA over AB over.
What is AB from our picture? And if we look at our tangent ratio, look at our tangent ratio on the bottom in blue. Is the hypotenuse part of that? No. So what do we need on top? Opposite. Which one's opposite here? I'm sorry? How many letters do I need for a line? CA. Thank you. So the opposite is CA. Notice that it's across from it. What is adjacent to it? BC. So my point here is, notice how these can change depending on which angle I'm looking at. In the first picture, my CA on the bottom was adjacent, because I wanted angle A. In my second picture, CA was opposite, because I wanted angle B. So please be careful about which angle they're looking at here. Okay? We're going to do one more practice. I want you to find tangent of X. It's going to be something over something. So we need it to be, what's the definition of tangent? Opposite over adjacent. So we need whatever's opposite to S. So I'm going to do it in green. So here's S. What side is opposite or furthest away from it?
Yeah.
TR. So this is my opposite. What would be adjacent to it? Khalil? Or, sorry, Khalil? ST. And what's the last one? What's 82? Hypotenuse. So what do I want for tangent again? It's what over what? Opposite over adjacent. So if I plug in numbers, what would it be here? 80 over 18. Okay? 80 over 18. Tangent of R then. Now it's a new angle. It's a new angle. So instead of the green, we're now looking at the red. So notice how R changed its location. What is opposite to R now? Justin? ST, very good. What is adjacent to R now? Khalil? How many letters? SR is adjacent to it, but remember, this one always takes priority. Yeah, TR. So Khalil, what would the last side be then? What would SR be? Okay. What is always across from the right angle? Across from the right angle? Hypotenuse. And the hypotenuse is always the hypotenuse. It does not change. So notice how the opposite and the adjacent change depending on which way I look. But the hypotenuse is always going to be the hypotenuse. Okay? So what is opposite angle R? 18. What is adjacent to angle R? 80.
No.
Notice we did not use 82 because that is my hypotenuse. And remember, the tangent ratio is tangent equals opposite over adjacent. There is no hypotenuse there. We can just ignore it. Okay? Does this make sense to people? Yes? No? If you have a calculator, your homework today will ask you to write this as a decimal. If you have a calculator, that's great, plug it in. If you don't, you can leave it as a fraction like that, that's fine. Okay? Why don't you try those on your own, please? And that's where we'll finish today. Would anyone like to do it on the board? Clear? Don't you, I've lost again. Okay. I can't remember now. Who can help him? What'd you do, Khalil?
I ain't doing that. I just done it. You're not talking about magic.
What? Alright, try again.
It's magic, I don't know.
Okay, can I get you started?
Go ahead.
Alright. So we're going to get started with tangent. So what is the definition, Khalil? Tangent equals?
Opposite over adjacent.
Okay. Opposite over adjacent. So if I want to do the tangent of K, which angle do I need to look at, Khalil? Which angle am I looking at?
Okay.
Okay. Which one is opposite of K?
Okay. No. The 15.
The 15? So this is opposite.
Yeah.
What's the hypotenuse always?
17.
The 17th. The longest side is also across from the right angle. And then what does the 8 then have to be?
The adjacent.
Adjacent. So after you do that, all you do is plug it in. What's your opposite value?
What?
What's the value for your opposite side?
15.
15. What's your adjacent side?
The 8.
8. Done. Does that make sense? Khalil, do you want to do the tangent of J or no?
No, I'm fine.
Okay. If you can, you should have. Tangent of J. If it helps, highlight in J. The hypotenuse is still the hypotenuse because it's still across from the right angle. However, what's the new opposite? What number?
8.
8. And what's the new adjacent, Stephanie Reyes? What is it? 15. Good. So if we're going to write tangent of J, it's going to be what over what, Cindy? 8 over 15. Before we stop, notice that these have switched. They're the reciprocal. I have 15 over 8 here, 8 over 15. Okay? Only use acute angles for trig ratios. Only use acute angles for trig ratios. So if you notice from my picture, we only did the trig ratio, the tangent of K and the tangent of J. We completely ignored L. You see how we ignored L?
Yeah.
And on the last problem, we completely ignored angle T. So when you're doing these problems, you're only going to want to use the two acute angles. Okay? Your homework for tonight, whoops. Your homework for tonight is 7.5, numbers 3 and 5. Number 3 and 5. These two problems are very short. I recommend you do them before you go home so you can leave your textbook here. Alright? They're very short. We're gonna pick up there on Monday. Have a great weekend, everybody. Adios.
Yes, ma'am.
Develop my journal.